Today we are going to study a concept like gravity. Okay, we are already familiar with the gravity, isn't it? So we are already studied in our class Newton's equations of motion. Okay, so today we are using that to demonstrate or measure a height using Newton's equations of motion. So before that going to that answer, we are playing a game. So I have 100 rupees. Okay, I have 100 rupees. I'm just offering you this 100 rupees. If you catch the 100 rupees, I'll say that I'll put the 100 rupees from here. If you catch the 100 rupees, you'll have the 100 rupees. Okay, that's the thing. So every one of you will get one chance. Okay. Okay, first one. Yeah, let's see. I'm putting. No. Actually, you cannot use these fingers, okay? Otherwise, you can only use these two fingers. Otherwise, you can have this 100 rupees. Because if you touch on this 100 rupees, you will get the additional time to catch this 100 rupees. You just need to only use these two fingers. Okay, you can try with your friends also. Okay, just try with you. Okay, no, no. Okay, no, yes. See, no, you don't. Okay, so have you noticed that you couldn't catch that because there is a reaction time. Okay, reaction time. That's another concept. I'll teach you later. Okay. So this is 100 rupees, and let's measure the reaction time. How much distance that your brain take to process all the stuff and catch the catching distance. So let's confirm this with the scale. Okay. Let's do another experiment. Measure the reaction time using the scale. Okay. We do the same experiment because I put the scales from above level of your hand. You just catch the scale. So let's measure how much distance it will travel while your brain processing the falling of the scale. Okay, that's it. Just try this one. Yeah. No. I'll say it. Yeah. Okay. We can see. Come to the camera. Nearly 16 centimeter. Okay. Before you catch, you just pass 15 centimeter. For this one. What about you? This one is about 15 centimeters. Okay, let's try with it. Okay. Okay, this one is perfect. Actually, this one is 10 centimeter. His shortest reaction time. Okay, that's the thing. So, we already said about the concept, Newton's equations of motion is in it. So, you are already familiar with the equation S equal to V0 t plus half a t square. Okay, here in the equation we have V0 is equal to the initial velocity and t is the time taken to travel and s is the distance travel and g is equal to 9.8 r. We are already familiar with it. Okay, that's the thing. So if I want to measure the height of him, for example him, we just use a stopwatch. Okay, stopwatch to measure the height, and there will be an error because if I put it on the stopwatch time say 0, there will be a reaction delay, isn't it? Reaction delay is there because about 10 or 20 centimeter. We have measured this one as actually something microseconds. That is the reaction time delay for an average human being. We just calculate this one and using another method. Okay, don't bother about it. We just need to incorporate this thing into that result. That's the thing. So let's measure your height using this method. Is it okay? Okay, let's see that. So we have a 1 rupees coin and another stopwatch. We already familiar with the reaction, isn't it? So if the same person putting the coin from a particular height and using the stopwatch, there will be no reaction time. Actually, we are doing together, so we won't get any delay like this, That's it. But there will be a delay while the coin touching the ground. So we can get at a time, and there will be a reaction time delay. So just let's measure this one. Let's see how much it's gonna get this one. Okay, that's the thing. So can you do that for me? Can you do that for me? Just the measure the height of his. Okay. Okay. You know how to start turn stop the clock? Okay. So using one hand, you just need to let's see here. Come. And you are okay with what you are going to do. Okay. This is the approximate height. Okay. Isn't it? Just do that. This is what we get 0.74. Okay. We get this 0.74. Let's note this one. Okay. And can you come? We just do the same. Okay. This one. Okay. 2 times stretching, okay? Okay. Okay, I'll hold this one for you. You just need to like hold, yeah. Okay. This one is 0.80. Okay, that's the thing. And I will also do that. Okay, for you. Give me the point. Okay. No, I'm just doing the same, nearly same. Okay. I got it as 0.61. Okay. So now this is completely okay. There will be some error. So we got 3 different results. Okay. So we'll take the average of this one. Okay. If we continue the trials, we'll get the accurate result. And let's calculate this one using the paper. Okay. We'll continue the result to an average form. Maybe we can continue to add up all these results and divided by the number of trials. We'll get the average. Okay. Then we can measure the height of the person. The same thing will be applicable for the buildings and other steps also. Let's measure this height also. Okay. We have the tape, isn't it? No, I don't think so. But we have the tape or the measurement method is over there. Let's see what's going to happen. Let's measure the height of the person. Okay, as we did earlier. So just measure his height. Yeah. Let's see. So thing. Yeah. What is his height? Yeah, it's nearly 150 centimeters. Okay. So let's calculate the height using that equation also. So, then we can verify that thing. We get the right answer or not. We can verify that. Okay, that's the thing. So let's verify later. Okay, now we can wind up. Thank you.
So here we are moving directly into the calculations. Because we are the same person is holding the calculator, the stopwatch and the coin. So we are not considering the initial reaction time because it will be a little negligible. So while the coin is hitting on the ground, there will be the reaction time is only applicable. So that's the thing we are calculating, or we are considering actually. So to reduce the error. So what are the errors that may occur? It varies with the personal error or varies with the person or personal error or something. Okay, so let's go directly into the calculations. Let's go to the calculation. First, we are finding the average reaction time. Our scale readings are 20, 22, 80, and 90, and 21 centimeters. These are the experimental data uh, from the scale experiment, scale catching experiment. So we are finding average will be 20 centimeters. So from this data, we can find the average reaction time of a particular student. Okay, so put it on the equation. S is equal to V0 t plus half a t square, and all the things are given in the SI units. G is equal to 9.8 and V0 is equal to 0. Putting on the equation, we will have t is equal to nearly 2.201 seconds. That is about 200 milliseconds. It's actually a given data, but we just verified the data. So we are verified the average reaction time is 200 milliseconds. Maybe we can use this data to find the final answer. Otherwise, we just the data from the next experiment can use to that we can use to find the answer. Then just reduce the scale measurement. It is there are 2 methods. I'm just using this this reaction time and decreasing from the next data of next experiment. That's the way I'm using, but it's possible to use both the methods. Maybe we can minus this value, the scale value or the measurement scale catching experience measurement value from the next experiment. But I'm using this method. So coming to next measurement, our readings are 0.7, 0.8, and 0.74, 0.76, and 0.75 centimeters. Sorry, seconds. These are the data from the second experiment. That is finding the height. That's the thing. So we are finding the average. We will have 0.75 seconds. Putting it on the Newton's equation, we will have s equal to v0 plus half gt square is equal to. Then we are reducing or minusing the term of reaction time. That is 0.2 seconds that we have found previously. This one. Okay. In this equation, we are just reducing the tr term. Then we'll have the answer is equal to 1 by 29.8 into 0.75 minus 2 the whole square. It's about 1.48 meters. and our measurement value or the height of the person is actually 150 centimeters. There will be a 2 centimeters error. That may be the human error, but we try to maximum reduce a maximum error in the experiment by averaging the reaction time and averaging the measurements of the second experiment, like the time finding experiment. Then we'll have a 2 centimeter error or the deviation from the actual value. So these are the method we can use to find exactly the exact answers. So that's the thing. These are the things we have to keep in mind while doing the experiment. What are the error can be occur? Here we found that the errors, mostly human error, the error system can be neglected for the minimum heights or a height in the for a building or a person. Here the error systems can be neglected, but there is the error possibility is actually from human error that we can reduce using the averaging method. Okay, that's the thing. And just we found the answer without using a tape. We'll have the answer is 1.48 meters. Is actually 1.148 centimeters. That is the answer from the calculation. But the actual height of the student is actually 150 centimeters. And this is one of the scientific way of finding answers. So thank you. This is the method.